Hi, my name is Vamshi Komineni. I'm a Senior Program Manager in Azure Storage. My session during the Azure IaaS week is going to be about Azure Storage. We're going to cover Azure Blobs, Azure Disks, Azure Files, Tables, and Queues. Storage is one of the fundamental building blocks of Azure, and we'll kind of dive into it and look at how you can use Azure Storage for all your Azure service needs. If there's one thing you can walk away with from our talk on Azure Storage, it's to consider Azure Storage as a vital building block of your IaaS VM story, looking at disks for persistent data and looking at files for your SMB share needs, as well as considering Azure Premium Storage Disks for your enterprise scale-up workloads for SQL, for Exchange, for Dynamics, and so on. Interesting fact about myself, I've been working on the Azure team for over 7 years now, back when Azure was still called Red Dog, and started with about 25 to 30 people. Fun fact, we used to all fit in a conference room back then, the entire team that built storage, compute, networking, and now we're a much, much bigger organization with many more customers and a much bigger charter to change the world.
Welcome back to Level Up Azure IaaS for IT Pros event. This is session number 2 if you're watching on the live stream. If you're watching this in a recorded format, this is one of many different types of sessions. We're kind of organizing the days and the groupings of sessions together to be around different themes, and today's theme is around all the supporting infrastructure that's going on. We just had a nice session on networking. Now we're going to be talking about storage and all great and good stuff about the storage lines of things. Just a little bit of housekeeping. If you are part of the live stream, you can obviously ask questions that we'll get to throughout the session down below the player to be able to ask your questions there. They come up and I can see what they are and interject them and ask them to our guests. Likewise as well, even after the event, you can always use the hashtag #LevelUpAzure, and I'll be monitoring those ones to be able to go off and ask questions during and also after the event too. So lots of goodness there. And we had a couple of questions about people asking about Microsoft Virtual Academy. Currently, this is obviously a session and a live stream event that's going on here on Channel 9. Eventually, you'll probably find this material show up in some form on Microsoft Virtual Academy, and there'll be testing questions and points and things like that that can all count towards the Microsoft MVA type thing. But for now, we're just doing this as a Channel 9 live stream and having lots of fun with it, let me say. Let me just get right to the storage topic that we're going to be covering right now, because storage is obviously integral to everything that Azure does. And I've got Vamshi now joining us to talk about storage.
Excellent.
Welcome. Hello. Good day.
Thank you for having me.
And hey, no problem. And I know you've got some really cool demos lined up, and so I'm just going to kind of get out of the way and let you just dive right in and talk about some storage stuff, because I know storage questions came up a lot yesterday during the IaaS questions in Drew McDaniel's session. But I'm looking forward to hearing the architecture and how this all works under the covers.
Great. Well, thank you, Rick. And hopefully we'll get to answer your questions and through the slides and questions and answers afterwards. So, and hopefully the demo gods cooperate with us and we can actually show you the demos that we want to show you.
Fantastic.
So my name is Vamshi Komineni. I'm a program manager in the Azure Storage team. So let's kind of dive right in. So the first thing I want to show you is this Azure Data Center Regions slide, and we always show this almost in every talk, I think. The thing I want to call out here that's specific to Azure Storage is we are in every data center that Azure is in. Storage is sort of one of the fundamental building blocks along with compute and networking off the entire Azure stack. Every Azure service that you use and know of and use above these core services uses storage in some form or another. So as you look at using infrastructure as a service across the world, know that Azure Storage is in all those regions. So what is Azure Storage, right? And it's basically, the notion is it's the file system of our cloud platform, right? It's cloud storage. It's designed to give you anywhere and anytime access. We have a number of different abstractions, blobs, disks, tables, queues, and files. And we'll talk about each of those. It is very highly durable, available, and very scalable. We have almost 35 trillion stored objects and counting. We do almost 3.5 million transactions per second on average around the world, right? So that's an enormous number of transactions that we're handling. We're scaling. We're very dynamically load balanced for customer load. So that's something that as you take a dependency on Azure Storage, know that it's a very high scale, very high availability system.
All I can think of right now is just gajillions and gajillions of blinking lights all over the place across
Absolutely.
all the data centers.
Lots of blinking hard drives and SSDs and all that good fun. Yeah. So, just like every other cloud storage system that you're used to, you only pay for what you use. It's the utility billing model, of course. And Azure Storage, like other parts of Azure, is very open. We have a REST API for everything, so you can program to Azure Storage just via the straight REST APIs. But we're also very multi-platform friendly. We have our .NET client library, of course, to make it easy to program in .NET. We also have client libraries in Java and Node.js. We just launched one on Android. So we have a lot of different client libraries that you can get to as a programmer. But this session is sort of more about infrastructure as a service and how storage plays in there. So let's kind of start talking about that. One of the things I'm going to do is take a step back and actually talk about first blobs, tables, and queues. I'll be very brief on those things, and then we'll dive into the meat of the talk, which is disks and files. So one of the things I want to kind of talk about is how the PaaS side of storage came about. This is an IaaS talk, but we want to kind of look back and highlight that storage really was built as a storage system for our PaaS platform. As most of you may know, Azure PaaS came many, many years before Azure IaaS, and storage was an integral part of that system as well. So let's talk about the abstractions that are supported in that world. So Azure Blobs are your first abstraction. Basically, it's a highly scalable REST interface-based object store in the cloud. It's where you put your files. If you have a lot of files to store in the cloud, you have a lot of files to serve to your users, this is where you put them in Azure Blobs. Number of different scenarios. People use it for data sharing. So all of OneDrive and OneDrive for Business are built on top of Azure Blobs. People use it for big data computation, so storing raw logs and doing computation over them. If you use HD Insight or something, you're probably using Azure Blob storage under the covers, as well as backups. So if you're using Azure Backup or anything like that, if you're backing up devices, you are coming to Azure Blobs eventually and kind of using those. So if you have scenarios like this, that's one thing to think about, right? So there are two kinds of blobs. There are block blobs and there are page blobs. So block blobs are where you store your normal files. They're files that are optimized for sequential I/O. They can be up to 200 gigabytes each, and they're by far and away the most cost-effective storage on top of Azure. So if you have a lot of files, or you have a lot of very large files, and you're reading them sequentially, you'd put them in block blobs. The other kind of blobs that we have that are very relevant to our IaaS audience are page blobs. So page blobs are optimized for sparse reads. They're sparse files. They can be very large, and you'll only be charged for what you use inside that file. And they're really optimized for random access. And you read and write them in these 512-byte aligned pages, right? So this, kind of looks and sounds and smells like a disk, and you're absolutely right? Page blobs are what we use disks for. So the page blobs themselves can be up to 1 terabyte each, and we'll talk a little bit more about page blobs when we get into the disks topic. So these are Azure Blobs, right? So this is our unstructured storage. You can store hundreds of terabytes to hundreds of petabytes of data, no problem. So the next thing that we built on top of Azure Blobs, along with Azure Blobs, is a NoSQL store. So, before I go there, these are some of the customers that we have running inside Microsoft on top of Azure Blobs. We talked about OneDrive, we talked about SharePoint Online, but Skype, Xbox, Azure SQL DB, all of these different teams use Azure Blobs today, as well as pretty much every Azure service you've heard of, right? All of them use Blobs in some form or other to store their state. So another thing that goes along with unstructured storage is sort of this semi-structured, structured storage. We have a very high-scale NoSQL store, which we call Azure Tables, and it's essentially key-value lookups at scale. And the idea here is to store user information or device information, metadata for your service if you're building a service. Really, this is about having schemaless entities, going with the NoSQL theme, and with very strong consistency. for very flexible structured storage. It's really optimized for read-write by partition, what we call them partition key and row key indices. So if you have something, a data pattern that's really friendly to that, that's what we end up using. And one of the things we support here with the Azure tables is we support tables up to hundreds of terabytes in size, and we offer you dynamic load balancing based on the load. So your tables will scale performance-wise based on the load that's coming into them. And there are no limits on the number of table rows. There's no limits on the size of a table. It can be up to the size of a storage account, which is 500 terabytes today. You can also do about 20,000 entities per second per account on, when you're using Azure SQL tables. So very, very high scale. If you're using NoSQL, you're looking into that, that's something to consider. The third, and customers again for this inside Microsoft, again, every service you've ever heard of, inside Microsoft uses tables in some form or another. The biggest users, some of the biggest users of tables are Xbox and Skype. They use it extensively. Bing is another big user, and MSN.com. They also use these things extensively. So if you're doing anything with any of these services as a user of these services, you're using Azure tables under the covers. The third abstraction I want to talk about in the PaaS world are Azure queues. And once you have blobs and tables and you have these PaaS services, you need some way for these PaaS services to communicate with each other as well as communicate amongst components inside the PaaS service. And that's what Azure Queues provides. It's a messaging system at scale that's reliable for cloud services. Right? It allows you to decouple the components of a PaaS service or have multiple PaaS services talk to each other. It allows you to build persistent messaging or scheduling of asynchronous tasks, things like that. It's a very straightforward API. It has the canonical put message, get message, peek message semantics. We do have a couple of cool features there, like message visibility timeout, that allows you to handle crashes in your service, in your PaaS service. And we have an update message functionality that allows you to update progress or renew timeout, so you can kind of do incremental work on an asynchronous work stream. Just like with tables, there's no limits on the number of queues or the number of messages. And it's a very consistent programming model with blobs and tables. If you're already using those, it makes a lot of sense to use queues with your service. So these are sort of the building blocks that you can use by themselves or in conjunction with a PaaS service to build a high-scale, high-availability service in Azure today. Customers for Azure Queues, again, pretty much every customer you've heard of inside Microsoft uses queues in some form or another. So this is all great, right? We've talked about PaaS services, but this is an IaaS talk, so let's talk about IaaS.
Just so you know, I think this is highly relevant because I get tons of questions about the different types of storage that are out there.
Absolutely.
And it's not just what the IaaS VMs are actually using. So thank you for that,
no
for clarifying it.
So let's, Corey showed this slide yesterday. He sort of said, here's the pieces of IaaS, and he set the stage for the rest of the week in terms of saying, here's storage, here's networking, here's compute. So let's talk about storage in the context of IaaS and where that fits in. So this is a diagram, again, that Corey showed yesterday that says, hey, you have an Azure virtual machine which has an operating system disk and it has a temporary data disk, temporary disk whose contents can be lost. So one of the things to take away from here is that the operating system disk, this thing in blue here, is actually backed by the Azure Blob service, right? So it's a persistent operating system disk. This is what allows you to do things like capture an image or create a VM from a captured image and things like that, or allows us to move your VM from one physical machine to another in case of reliability problems and have your machine come back up exactly the way it used to be, right? So there's a disk cache, of course, to speed up performance on the node, but every write is written out to the Azure Blob service, specifically page blobs. The other thing that writes to Azure Blobs are all your data disks. So your data disks today end up on Azure Blobs, right? So that's one thing to kind of take away is your data disks end up on the same storage system that provides highly available PaaS services at mega scale, right? So every data disk that you have, whether you have 1 VM or 10,000 VMs, is coming to the same service that's running the Microsoft services like OneDrive, like Xbox, like Skype, and getting the same reliability guarantees, the same availability, and the same performance, right? So what about these disks, right? So disks are basically mounted as VHDs, as you know, and they're persisted as page blobs. Every write, as I mentioned, is synchronous and strongly consistent. We get 3 copies before we return a write back to you. So as soon as you're writing something to a disk, whether it's the operating system disk or the data disk, we're already highly available at that point. We do provide asynchronous geo-replication. If you need business continuity or disaster recovery scenarios, if you have things like that, you can turn on geo-replication on your storage account and get this asynchronous copy of this disk happening all the time behind the scenes.
And just out of curiosity, that asynchronous copy as an option is primarily going to be things from an architectural perspective, probably the data disks that we're going to be talking about as an asynchronous copy of it. Absolutely.
I mean, typically you would be geosynchronously replicating your data, so you have a story for business continuity if the entire data center were to go down. Yeah. So in terms of size limitations for these data disks, we talked about page blobs having a 1 terabyte limit. That's actually where the 1 terabyte limit for your data disks comes from. You can only have up to 1 terabyte data disks. You can't stripe many of these together. You can stripe up to 16 of them together to make a 16 terabyte volume. And you get about 500 IOPS per disk. So that's for standard disks, and we'll talk about premium storage as well. But for a standard disk, you're getting 500 IOPS times 16, so you're getting up to about 8,000 IOPS if needed. Right? So in terms of customers for Azure Disk, every IaaS VM. If you're running an IaaS VM today in our cloud, if you go to your trial and sign up and launch a VM, you're using Azure Disks, right? So that's sort of the base building block layer. So one of the things we announced very recently in October are Azure Premium Storage Disks. So customers are using this, and of course the immediate ask is, hey, I have all these high-scale workloads I want to run on Azure. I want to run my SQL servers. I want to run my Exchange servers. And I need much, much faster disks, much higher IOPS, and I need much more consistent latency than you're able to give from Azure Standard Disks. So we're sort of pleased to announce, kind of going into preview soon, Azure Premium Storage, which gives you an SSD-based storage. So it gives you very consistent low latency, very predictable I/O throughput, and we'll look at a demo of that. And it's really for high-performance scale-up type workloads. So if you have a SQL server on your premise that you want to bring to Azure, you want to look at premium storage disks as the way to bring that SQL server onto Azure. Right?
And we'll also, again, for those that are watching this in replay mode, this is current information as of December 2nd, 2014.
Yeah.
So if you're watching this in the future, it might already be available to you on your subscription.
Absolutely. So you should check it out. And just like we have 3 copies strongly consistent for your standard disks, we have 3 copies of your data stored on 3 different SSDs. So every write that happens is strongly, consistently replicated for you, right? So let's see, if we can get our demo gods to cooperate with us and kind of do a quick demo of different types of disks. So I have standard storage here, and what I have here is basically I've mounted a 1 terabyte, roughly 1 terabyte standard disk, and you can kind of see that it's just mounted as a volume. I can go in, I can look at it. I don't have a whole lot other than my thing in here. So I'm going to run a tool called IOmeter that allows me to test how good my performance is against this disk. One of the things I'm doing is I'm doing sort of a mixed read and write workload. So you'll see that come up. We'll be doing both reads and writes. And this is something I have to exit out of with the right resolution. And right away, you start to see that we're getting about 500 IOPS is what we promised. So 500, 600, you'll see this number fluctuate, of course. It's updating every second, so it's live data. You're getting about this much throughput. This is megabytes per second. And this is your read and write response time, right? So about 30 to 60 milliseconds. This will stabilize and drop over time. You're not using too much CPU. So, and if you look at this in sort of a speedometer style, you're getting right about 500 IOPS per second, right? So that's sort of a standard disk, and it's a single standard disk, so a single standard volume. It's not striped. You can always stripe up to 16 of these together. So then let's look at a premium storage account. And again, same thing here. I've kind of attached a premium data disk to my VM, and I have again about a terabyte volume that's attached. Again, I just have my some data in here for the demo to run or for the simulator to run. So let's go simulate some load. Again, I'm sort of running a mixed workload, and let's start that. And right away, you can see I'm getting about 4,000 IOPS, right? So 4,000 IOPS here very consistently. And if you're looking at standard storage, you're getting 500 IOPS here on standard storage. And on premium storage, you're getting about 4,000 IOPS. So fantastic difference. You're getting this. You're getting it very consistently. One of the other things to consider here is, let me exit out of this, is the latency. So we had about 30 to 60 millisecond latency on your standard disks. Here, your latency is under 10 milliseconds. And this is just early numbers. We're still tuning this. We're always improving this. So this is in preview. We're already able to do great latency numbers that are much more comparable to what you'd get on premise. Again, not a whole lot of CPU utilization.
Can I ask actually a clarifying question?
Sure.
Because we mentioned about how some of these features are available in preview. When we say it's in preview, that doesn't just mean it's Microsoft people that are using this right now. We actually have some special case customers that are using this data as well to be able to try it out in real world scenarios.
Yeah, and we kind of go through these different phases. Preview isn't in testing in the traditional sense of the word. Preview for us, we initially go through our own testing, our internal dog food.
Right.
We then go through a managed preview where we have a few trusted customers that we work with one-on-one and look at their problems and they're willing to take a bigger risk. So by the time we get to preview on a service, we're pretty confident that this stuff works. We might still be tuning it, we might still be changing things, but it works. It's supported like production. We're not going to lose your data or anything like that. So we do not provide a formal SLA, but in every other respect for our team, we treat it as production data.
We have one of the questions, if you're okay to take this one here from Colin. This is just a general question. What is the best way of creating a multi-terabyte drive in a virtual machine? Dynamic drive with Windows Disk Management, or can you present, say, a 16 terabyte like a logical disk to a VM?
Okay.
So really it's just a matter of how do you get past that 1 terabyte limitation that we currently have?
Absolutely. So that's a great question. You can create a dynamic disk from disk management in Windows. You can also use storage spaces. We actually recommend that you use storage spaces to create those volumes. Storage spaces are sort of a newer version, if you will, of dynamic disks and striping and all of that. So if you create attach your disks either via PowerShell or via the portal to your VM, you launch storage spaces, they show up as regular disks, and then you can create a pool, a storage space, if you will, from that pool of disks and stripe across there or mirror or whatever you need to do. Striping is what typically people are trying to do in IaaS in Azure, and that's how we want you to do it. One of the reasons there is with storage spaces, you can actually adjust the stripe size. So the default stripe size in Windows is 64 kilobytes. We actually recommend that you can go to a higher stripe size, right, to help with the IOs. You can go to a stripe size of 256 kilobytes or up to about a megabyte. 256 is sort of a nice sweet spot when you're creating volumes with storage spaces. And the way of creating that is exactly like you would do on your premises. You just run the storage spaces commands. There's good PowerShell automation there, so you don't have to do this by hand or manually each time.
Definitely, either through the traditional UI or through the PowerShell way is able to do it. The big thing is that you're doing this on the Windows platform the exact same way you'd be doing this on premises with DAS, the direct attached storage, except now you're just doing it for mounted VHDs in the virtual world.
Yeah, I mean, from our perspective, once you mount that VHD, it's a disk, right? As Drew said yesterday, it's exposed through the SCSI interface. It's attached as a disk. For all intents and purposes, the VM has no idea it's talking to anything other than what's a direct attached disk. Right? All the magic of talking to storage happens underneath the covers. So we're kind of still running this demo here. You can see I've kind of left it running. It's still kind of right around 4,000 IOPS, 3,900 to 4,100. So this is great. But we talked about scale and doing really scale-up workloads. So what happens when we put 32 of these together? So let me just switch to this VM.
You've got a VM with 32?
I've got a VM with 32 terabytes. 32 terabytes.
I can't wait to see this.
So that's a huge, huge volume. And I'm going to run the same workload, same iometer. And, let me exit out of this here. And voila, you are getting 60,000 IOPS.
Now, so this is off of your account, right?
This
is not on mine. So it's not on my bill.
Not on your account, not on your bill. But 60,000 IOPS. You can do some amazing scale-up workloads here with this sort of disk and our new D series and G series VMs.
Right.
Very high memory, lots of local SSD, and a fantastic high-scale disk backing all of that for your persistent data. So 60,000 IOPS here. And one of the things, again, your read and write response times, which are just as important as your IOPS. Sub 5 milliseconds, sub 10 milliseconds for sure. And again, these are preliminary numbers. We're continuing to tweak these, and we're continuing to make them better. Another interesting thing to note when you have this many disks attached is you're doing a ton of bandwidth off of this VM, right? You have 500 megabytes per second, and it consistently going off of that and read and write off of that VM. So that's something to take away from here is, we have standard disks today, we have premium disks coming soon, and you're going to get the kind of scale up you need for your workloads, and that's coming into preview very, very soon. All right, let's get back to our slides here.
I'll just let you know that right now on Twitter, everyone's freaking out about the IOPS and stuff. So that was an awesome demo.
It's my favorite demo to do, right? It's, people should see that number and go, wow, that's cool. So, let's switch gears, though, a little bit and talk about the other offering that we have for our IaaS customers that's very, very relevant, which are Azure Files. These are verbatim customer quotes, what's on the screen there, in terms of things that we've heard from our customers and say, hey, I really want a UNC addressable share for my VMs, right? I need two VMs running with a shared drive. One's going to write, the other's going to read, right? Or I have, configuration that I want to get out to a bunch of VMs, and I just want a file share, right? This is a very canonical thing in your enterprises. You have some kind of direct attached storage as a share, or you have some kind of NAS or SAN or something like that sitting there providing a pool of data, right? And we said, hey, how do we do this, right? One of the things you can do today, without Azure Files is do it sort of the old way, if you will, which is you have a data disk that you attach to your IaaS VM. You then share it out through Windows Server, right? So you can do that, and all your other VMs can read and write from that shared disk on that VM. The problem with this is you've got to go write some code or some way of sending config out to find this IaaS file share from the rest of your VMs. You've then got to, more importantly, worry about high availability for this VM, right? If this VM goes down, you need a way of remounting that data disk on a different VM, which takes some time. And you've got, you're kind of in this world again where you're dealing with all of these problems that you'd rather not deal with. You just want a share, right? You want a share that's reliable, that's available, that's performant, without having to do this dance of trying to share out a data disk. And our answer to that is Azure Files, right? So it's a shared network file storage. It does the standard SMB protocol. We support SMB version 2.1. And we take care of all the availability, the durability, the scale for you. Just like with page blobs and disks and tables and queues, you're coming to the Azure storage system and really reading and writing off of this very highly scalable, available system. With file shares, you come here, you talk to us, you get a share, and it works.
So literally, it's like a file share PaaS.
It's a file share PaaS.
But it's inside your subscription for your VNet for different resources.
Absolutely.
Now, I had a question. I don't know if you can answer this one or not, but there was a question that came up yesterday about why SMB 2.1 and not something more recent. That's just the way that the common level that we set for this offer, or anything else along those lines?
Yeah, I mean, I think one of the reasons we kind of picked SMB 2.1 is that was one that was sort of a common standard spec, and we could also make it work on our Linux VMs.
Oh,
right?
True.
So you can today go mount these shares on your Linux VMs just as well as you can on your regular Windows VMs. So. That being said, we are looking at SMB3 and things like that, so
Correct.
we have nothing to announce yet, but in preview right now, SMB 2.1, but we are looking at newer, more recent SMB versions as well.
Very cool.
All right. So again, coming back to this virtual machine storage architecture, we have the OS disk and the data disk going to Azure Blobs. We can now add another form of SMB shares that you'd mount, just like a network share, that goes to Azure Files. And both of these are on the Azure storage system, right? So you can get all of the benefits of availability and scale, whether you come via data disks or the OS disk itself, or whether you mount an SMB share or you map an SMB share. So what are the scenarios you can use this for? Obviously, if you have on-premise applications that require a file share, right? You have a bunch of VMs, they read and write from a file share. You can now have a file share that's in Azure, bring your Azure VMs, your IaaS VMs, and just connect them to that share, and everything will work just exactly the same way. You can share data across VMs and applications. So if you're able, you have some VMs reading, some VMs writing, all of that just works. You can share settings, right? If you have services, and again, the canonical pattern is you have config files on a share, and your services start up on premises. You can have that dynamic work here. It's actually also very, very useful for dev test debug sort of things, right? I almost always have on my IaaS VMs, I have a little share mounted with all the sysinternals tools, for example. That's sort of my standard thing. I put it on a share and I have it available. I can just get to it via NetUse. So it's also useful if you're doing sort of dev scenarios type of thing.
Wait, I thought all the sysinternal stuff was available to every single VM because Mark is the CTO for Azure.
Well, you can go to live.sysinternals.com, always get to it, but it's nice to put it on a share.
Very, very true. There's actually a question that came through asking about Azure Files architecturally. Is it only available to certain VNets if you make them available off of VNet, or is it available to all the VMs on your system? What kind of restrictions are there for it?
That's a good question. Basically, today, the authentication model for a share is off of the storage key for the storage account. So anywhere that you can have the storage key, you can actually have the share. Right?
Okay.
It's not restricted to a VNet per se. We are looking at doing things better than just having your shared key, kind of which is your password in a way, required for mounting or mapping a share. So, but today it's not really tied into the concept of VNets. It's really about saying where do you distribute your storage key to map the share.
And I guess it also makes sense too from a compatibility to make it available to a wider range of clients too. Some of them may not have the ability to map a drive to a UNC share name that has an ACL or an access control list that's on it as well. So it makes total sense. Okay, thank you for clarifying that.
No problem. So we've been talking about how the SMB 2.1 protocol is what we support, and NetUse just works, and we'll do a demo of that in a bit. All the Windows file APIs, all the C runtime APIs, all the .NET APIs, everything just works, right? Again, from the perspective of any code or any application you have running on those VMs that have the share mapped, it looks like a share, right? And there's no concept of there's this giant storage system behind the covers offering up all these other goodies. It's just a share, right? All the standard file system semantics are supported under the SMB 2.1 protocol, so you can move and rename files, you can move directories, you can do read-only, you can get change notifications. So if you have a .NET API that responds to File System Watcher, that just works, right? The other cool thing with Azure Files is we provide REST APIs still for it. So if you're outside the data center and you want to get access to the file share, you can actually do it through our REST APIs and our client libraries. So it allows internet access, if you want, to the same shared file system that your VMs inside the data center, inside the Azure data center have access to. So this allows you to kind of build hybrid applications, update configuration, read log files, whatever, from your on-premises, as well, while having all this stuff running in the cloud. Again, we have a variety of common APIs that you'd expect around file handling that are supported via our REST APIs. So in preview, it's in preview today, Azure Files. And you can go sign up today on the preview services page. We are approved almost immediately. We allow you to create up to 5 terabyte shares and up to 1,000 IOPS per share. However, there's no limit on the number of shares that you can create. So you can create as many shares as you need up to the size limit of the account, which is 500 terabytes. So you can kind of go play with this today. You can create the shares through Azure PowerShell and then use your standard NetUser map drive to connect. There's already a bunch of internal Microsoft services using Azure files and things for full text indexing, or actually the canonical case that our external customers have, which they have existing legacy applications that require shares. This was a very easy way for them to move those workloads to Azure. So let's do a quick demo of Azure Files. This will be a much simpler and easier demo. Hey, here's our IOPS thing, still running away, chugging away at 60,000 IOPS. And actually, let me go to.
Down those machines.
I will get charged a ton of money if I keep this running.
Well, I do want to clarify one thing. This came up on the Twitter feed for hashtag Level Up Azure. Premium storage is going to be available for the D series machines and the G series machines.
That's correct.
We're not talking about connecting these up to the A series machines at all.
That's right. So Drew yesterday spent a bunch of time talking about the different classes of VMs, and these are premium storage is going to be available for the D and G series VMs. Part of that is how we do our networking interconnects between our scale units. We need much newer, much more high bandwidth, low latency interconnects between our storage and our compute clusters, and that's available in the D and G series SKUs.
Cool. Thanks for clarifying.
All right. So yeah, still chugging along. Since the start of the test, we've consistently had 60,000 IOPS. So I just like showing off that demo. So let's talk here about files, though. So what I have here, if this cooperates with me, let's try the other VM. Okay, perfect. So what I have here is a already mapped share. So you can see it just looks like a network location. And if I can drag this up a little bit more, I kind of get this, hey, it's mapped to Vamshi-K. Let me see if I can zoom in on that. It's mapped to Vamshi-K file st. That's my storage account name.file.core.windows.net. It's 5 terabytes, right? That's how much I have. And it's just a share. So I can go in here. I have some stuff already. And let's say, I'll do the goofy thing. I'll just create a text document. Let's call it IaaS week, right? So I've created this text document, has nothing in it. Let me go back to my first VM. And I already have that show up, of course. Let's go in here and see if we can save something here and close that out. You've seen that it's updated here. And if I go back here, whoops, I don't know why it wants me to do that, but hey, here you go. You have basically what you'd expect. I'm reading and writing to a file share, and it works.
And obviously, this is, just to clarify, this is not a cluster shared volume. This is something that is available so you can have access to 2 different machines to the same point. You can't obviously open up the document at the same time from 2 different spots. And all that sort of regular file locking stuff exists. You'd expect on a traditional file server.
Absolutely. Right. So this isn't some magic panacea that's going to solve the file locking and all that problem. It's going to give you, the same set of benefits and the same set of problems of the file share. It gives you, you still have to deal with consistency and conflict resolution, things like that if you have multiple writers to the same file. What it does allow you to do is sort of the single writer, lots of readers very easily.
Very true. We got a question up there from Breg asking about, are the files on Azure Files also stored on multiple locations, 3 copies, strongly consistent with the same way that we write our data?
That's a great question. So absolutely, yes. Everything in Azure Storage is 3 copies, strongly consistent. You have the option of geosynchronously replicating files data as well. So that's something to keep in mind. So every write, as I wrote this file or created this file, the ACK when this file was created was, okay, I've gone and written to 3 different copies.
And in case you're not aware when you're watching this in replay or even live right now, you're able to set that kind of policy for is it geo available or is it just locally available? When you create your storage account, you choose and specify that when the storage account is created.
That's correct. Yeah, you create that with your storage account. You can play with it in the portal or via Azure PowerShell. We'll talk a little bit about that as well. All right, so this is great. I've kind of shown you a share here. One of the things I want to do really quickly is show you what it takes to create a share today. If you go in today to the portal And let's just do that really quickly and go to my storage accounts. So I was showing you this vamshike file st storage account. The first thing I'll see if I go to the dashboard is this endpoint. Let me just zoom in on that. This endpoint is what's allowing me to talk to the file share. And I can talk to this because it's an HTTPS endpoint. This is how I get to it via REST if I need to. Right? So I have this on any preview-enabled subscription, and you'll see that's why we have the preview tag. We, of course, have Blobs tables queues there. So how do I create a new share on this storage account? So let's quickly run through that. Today, I have no way of doing this in either the old portal or the current vCurrent portal or the vNext portal. In preview, you'll have to do it via PowerShell. So I've come in here. I've kind of connected to the same Azure account that I have that I'm showing you on the portal. And let me just kind of run a few commands here. So I've kind of got that, and so I've gotten my subscriptions. I have two subscriptions, MSDN subscription and a regular pay-as-you-go. I've selected the MSDN subscription because that's where my storage account is, and I want to go get my storage account, show you that that's indeed available. And this is all live running, of course.
I like how you're actually using your MSDN subscription for this.
Oh, yeah. And one of the things that happens with MSDN subscriptions is last night I ran out of credits because I'd run my demo machine. So that happens to us as well. So I have a bunch of different storage accounts, but the one I'm looking for is this vamshike file st. So you can see it's in that subscription. Again, I see those endpoints if I need to. But what I really want to do is create a new share. Right, so I'm going to go create, this is my long key. I'm going to copy this. That's the reason I have this instructions up here. And go ahead and create a context variable with new Azure Storage Context. So that's my first step once I connect to a subscription. I create this context, and then I want to create a new storage share. And that was it, right? I've gotten a new storage share, and it tells me, hey, you've got it, as it was modified. In fact, if I try to create it again, it's going to give me an error and say, you've already created your share.
Okay.
That's why I'm giving you a 409, right? So I've got this share now, and I want to map it on the VMs I was showing you. So again, here's my netuse command. Let me zoom in on this a little bit. Here's my netuse command. I am net using to my storage account. And whack the storage account.file.core.windows.net. Whack IaaSweek is the share I just created. I'm providing the username, my storage account, and then I have this long key that actually is my storage account key, and I'll have to go roll these keys over right after the demo, but we do that. All right, so let's copy that, and let's go to our VMs, and let's go to PowerShell. On there. So I have a netuse, Y drive, and I want this IaaSweek share that we just created. Let's go ahead and run that. So that's created. Let's go back here and go out to this PC. And there you go. I have an IaaSweek share that's mapped. It was that simple, 30 seconds to go create it. Soon we will have the ability to create this through the portal as well, so you don't have to kind of drop into PowerShell if you don't want to. But for most people, this is an easy scriptable way of creating shares, as many of them as you need for your different needs.
I'm trying to remember. I'm pretty sure I think I've seen a blog about doing exactly what you're talking about for being able to easily create the share and be able to map it. So
absolutely,
definitely out there on documentation.
Yeah, it's on Azure.com. In fact, if you go look for Azure files, there's a kind of screenshots and everything that walks you through
step-by-step walkthrough to be able to do it.
Absolutely, yeah. Great.
And in case anyone was interested, that particular file share that he's using in the demo will not exist after this, so there's no point in you trying to connect up to it.
Absolutely. A couple of minutes after the demo. Yeah. So, one of the things that comes up when we talk about this, of course, is, what are the differences between disks and files? You clearly offer both. They're clearly very relevant to the IaaS world, both of them. When would I use one versus the other? What's the differences between them? So disks, of course, the first thing is they're required for booting. You don't require a file share to boot an IaaS VM. So the OS disks run off of disks. The biggest difference is going to be that disks are isolated to a single VM. You can only mount a disk on one VM at a time, right? Your disk is effectively locked to the VM once you mount it. Versus the file share, you can always map on many, many VMs and you can share, right? Disks do support snapshots and copy disks today. File shares do not today in preview. So that's one difference. If you're looking at doing snapshots and stuff, you probably still want to stay with disks. Configuration. Basically, disks can be set up via the portal and all of that at connection or VM creation time. Azure files are typically something you connect to after boot. So you can set up something to do with net use, and you have that connection. Again, authentication. Disks are automatically authenticated because you create them with your subscription. You saw me using the NetUse, the storage account key there for file shares. In terms of cleanup, you can always clean up resources with the VM. When you delete a VM, you can choose to delete your disks. For file shares, you have to kind of go delete the file share if you need to, which makes sense. They're not connected to any specific VM. Both of them provide access via REST. For a disk, though, you can only access it as a single blob via REST from off-premises. So you can just get the whole disk and then mount it on your VHD on-prem. But via REST, you can get individual files from your file share if you're off on your premises and wanting to get to an Azure file share. 1 terabyte disks, 5 terabyte file shares. So that's something if you need more data and you don't want to stripe and deal with all of that. If you need more space, you might consider a file share. In terms of IOPS supported, disk supports 1,000 IOPS per share. A file share supports 1,000 IOPS per share versus a disk supports 500 IOPS a disk. Both of them have about 60 megabytes per second throughput, about half a gigabit per second for throughput off of your VMs. Right? So that's sort of the differences. Which one you use depends really on what your need is. If you're storing data that's exclusive to the VM, you're probably using a disk. If you have any kind of shared needs, definitely Azure files are a viable alternative. You should look at that and see if that fits better with your architecture. So I want to switch gears a little bit here and talk about the Azure storage architecture. We've kind of been alluding to this all along by saying everything is built on the same platform. We've introduced blobs, tables, queues, disks, and files at this point. The thing I want to show you is that at the bottom layer of all this, we have a large distributed replication layer that takes care of kind of committing your data to those 3 copies, takes care of dealing with disk failures, machine failures, rack failures, all of that stuff. So there's one distributed replication layer for all of these abstractions. And above that, we have an indexing layer and a load balancing layer. So again, as all of your data comes in, depending on your read volumes or your write volumes, we take care of all the load balancing for you across hundreds of thousands of servers and making sure that you have the scale when you want it, right? And then we have these endpoints, or front ends as we call them, that provide the REST interfaces, or in the case of file shares, you provide both REST and SMB 2.1. And on top of that, you have your VMs, you have your client libraries, whatever you need that accesses this. So this is a very, very powerful architecture because it allows you to take these fundamental platform capabilities and provide it to every kind of endpoint or abstraction that we have today or that we come up with in the future. All of them get the benefits of the distributed file system layer, and they get the benefits of the scale out and the load balancing. Right? So if you want to read more about this, you can do a search for Azure Storage SOSP, and there's an academic paper that we published a few years ago now. The architecture is still very much the same. It's worth reading if you're kind of curious much more about the nuts and bolts. There's a lot of prior history on distributed cloud storage systems, and we're happy to kind of contribute back to that literature openly about how our system is built and architected. Yeah. So another thing that I want to talk about, again, what are the platform capabilities that we provide? So we've been talking about geo a little bit, access control a little bit, scalability. The basic platform capabilities that we have apply to all of these abstractions. And let's talk about each of them very briefly, right? So durability options. We've been talking about geosynchronous, geo-redundant storage and asynchronous replication. So we have three kinds of storage accounts. You can durability, you can choose for a storage account. When you create them or later, you can kind of upgrade them, if you will. We have locally redundant storage, which is the 3 copies, strongly consistent, stored locally in a data center. Resilient to disk failures, resilient to machine failures and rack failures, but not if the entire data center were to go down. Right? And so the next step up is zone redundant storage, where your 3 strongly consistent copies are stored in multiple facilities in the same region. So they're still within a very, very small latency envelope, but they are insulated against a building failure. And the final step up is geo-redundant storage, where we not only store the 3 copies locally, we asynchronously replicate that to another data center hundreds of miles away. And we take care of doing that for you. And that's something none of the other cloud storage providers provide today, which is this great ability to asynchronously move this data to another data center and help you with your business continuity and disaster recovery scenarios. We also provide read access from the secondary, so if you ever need to read from the secondary, you can do that while the writes are happening to the primary. So that's sort of our durability story, and you can pick and choose these things when you create storage accounts. So as you're creating your Azure IaaS VMs, you can kind of say, what kind of durability do I want for the data that I'm going to be storing with these VMs? The next thing that we want to kind of talk about as a platform capability is access control. Right? We use a symmetric shared key system. For most IaaS data disks, you don't worry about this. You just create these disks in your subscription, and stuff is just kind of hooked up for you. But if you're using the PaaS side of the house or file shares, for blobs, tables, queues, we have these notion of shared access signatures. Right? So the idea here is delegated authorization. You can take your key and then give a delegated, scoped access to untrusted users, untrusted devices, or what have you. So you can, for example, say, you're allowed to read this data but not write or delete it. Or you're allowed to write to just this subsection of my storage account, and you're not allowed to read anything else either. So you can kind of set this up with shared access signatures in a pretty fine-grained, pretty interesting way. You can do things like time-bound signatures, where you can say, I'm giving you access for the next 5 minutes to just this one file, so you can upload a backup or something like that. So it's something to look into if that's interesting to you. On the scalability side of the house, every storage account comes with 500 terabytes of data, 20,000 transactions per second, and up to 10 gigabits of ingress and 20 gigabits of egress if you're a geo-redundant account, and 20 and 30 if you're a locally redundant storage account, right? So lots of scale per storage account, and you can create up to 100 storage accounts per subscription. So you can have 500 terabytes times 100 for your data. You can, of course, also create multiple subscriptions. This, by the way, is how internal services, this comes up, how do internal services work with us? We don't treat our internal services, our Microsoft first-party services, any differently from the way we treat our customers we work with you. They don't get any special passes or special keys. They come in and work within the constraints of the system that we provide to our external customers. And we're very strong believers in that, in the sense of we need to use our system the way it is, with its pain and warts and everything. And that way we build the best system for our customers. Right? And the last thing I want to touch on here is storage analytics. So storage system has very, very rich analytics that you can go enable in the portal today. And it allows you to get metrics, which are like perf counters for storage, and logs, which are basically like transaction logs. So you can kind of do some very interesting analysis of everything from how many transactions per second am I getting, what's my latency. All of these things are very transparently exposed to you, so you can kind of do the diagnostic, the monitoring, the diagnostics, and the debugging if you need to, before you come to us and say, hey, you have a problem with the account. And we're kind of very transparent about showing you end-to-end latency versus latency in our own system, so you can kind of look at that and say, where's the problem at, and help you sort of self-serve these problems. So the storage analytics is sort of this key search term if you're looking at that.
And I will just point out, just to remind people, that if you go back and take a look at Drew McDaniel's sessions on Windows workloads, architecture and performance, he talks about how many VMs per storage account to get the best IOPS and how to set them all sort of stuff up. So that's one of our other pre-recorded sessions you can catch on channel9.msdn.com.
Absolutely, and the way to verify, if you can put more VMs or not on a storage account is to use storage analytics and say, how am I doing, right? Am I getting close to that 20,000 number or not? So I want to kind of end here with a small short video from the Xbox team, which is one of the earliest and largest users of Azure in general and Azure Storage in particular. They use pretty much all of our abstractions, data abstractions, and there are many, many different teams within Xbox that use Azure Storage. And one of the takeaways, what I leave you with is, if you're an Xbox gamer, if you love the Xbox One or the Xbox 360, you cannot turn on an Xbox One today without continuously talking to Azure Storage. So that's next time you turn on and you're playing Halo Master Chief, or you're playing one of the games that are coming out this holiday, think about that in terms of us taking a bet on our own storage system and building the entire Xbox Live services off of Azure. So let me play this video here.
The Xbox Live service powers a lot of the social experiences on the Xbox console. Things like competing with other players, playing with other players in the same game, either cooperatively or competitively, and then also tracking your progress. We hope that by providing these social features or these challenges features or things that kind of go beyond the gameplay, that we're able to give you a much better, more enjoyable experience when you're on our platform. All of our services use Azure Tables for their base layer of figuring out where a storage account is located. So at the end of the day, you use an Azure Storage account for your blob and table storage, but we use many of those for each service. And we do that because we want to be able to get more of that elastic capacity out of Azure, and also because we don't want to pull all of our data in one place for things like disaster recovery purposes. So every service in Xbox Live uses a common platform based on Azure Tables to figure out where each user's data is stored. Xbox, when we ship a new feature, millions of people use that feature almost instantaneously, and that's a significant amount of load that we've spent the last 10 or 12 years trying to figure out how to handle and scale for. And as we moved to Azure Storage, we were concerned that could this partner service do the same thing that we were already doing internally? And it was fantastic that it could actually do that. We've never seen an issue where we deployed a new feature and Azure was the bottleneck that caused us to not have that feature work. As we look to the future, we want to be able to get things done faster and try things out more. And we're going to make mistakes, but we're also going to do some really great stuff. And the faster that we can iterate on these things, the faster and more likely we are to make our customers happy. We want Xbox to always feel like the best place to play games. And that doesn't just mean that we have the best games, but that also those games are more fun on our platform. The more and more data that we can push through the system, and the more data we can retain and massage and process, the easier it is for us to light up those experiences. And that's really something that Azure helps us do. We don't have to think about how many more servers we have to buy to do this, or how many more hard drives do we have to buy to store all this stuff. We can just know that almost infinite capacity will be there, and we can build almost anything that we imagine to enable those experiences.
Thank you.
Fantastic. I got to say, that's a great way to end the session on storage. Thank you very much, Vamshi, for coming in today. I very much appreciate it. It was very enlightening to get the separation between the different types of storage, how we can use them, and also introducing premium storage. Lots of tweets and discussion about that was going on online with the IOPS demo, so don't forget to shut those guys down.
Absolutely.
And I'll just say that we'll be right back after the break, coming up with some disaster recovery stuff on Level Up Azure.
Great. Thank you.